Hi guys, very good day, and welcome to Buzz with MXN. Today we are going to discuss a very important topic in the networking world, that is a domain name system. This is something on which whole of the internet works, and if this fails, everything is failing. So, talking about the DNS, what DNS stands for is domain name system. So, as the name suggests, it is basically what it does is it basically maps a particular host name like www.google.com, or for example like www.amazon.com, to a particular IP address through which we are able to connect to that site via our web browser. So let's take an example of Google. There's a Google server over the internet that we want to connect to from our local machine, from our internet. What we will do is basically we will need to have we will just type in on our browser. We just open our browser. We'll just type in www.google.com. So and we press enter. What happens in the background? How we are connected just by typing www.google.com to a Google server. So what happens in the background is what uh, is DNS all about. How the host, this www.google.com is the host name. So how this host name, this fully qualified domain name, is mapped to a particular IP address, and we are able to view the contents of Google over our screen, over our laptop. So the main points that we are going to discuss about DNS are uh, what it is used for, what it basically stands for, what it is used for, what are the steps that that our laptop or our end client goes through in order to retrieve the information or retrieve the IP for a particular host name, and we get connected through which we get connected from our browser to that website. So DNS is just like a phone book over the of the internet, where every host name is basically mapped to every IP address. As humans, as we humans are, we are very bad at remembering the numbers. That is the reason we are not able to uh, basically write in the IP addresses or remember the IP addresses to connect to our website. What we do is we remember the domain names like google.com or amazon.com or facebook.com in that case, and then we interact. But what web browser does is it cannot basically it does not understand the wordings. What it understands is the IP addresses. When it has the IP address, then only it can basically connect to that particular site. And DNS translates the names of translates domain names to IP addresses. This is what I have already stated, that DNS basically does is what it does is basically maps or translates basically the IP domain names of Google, Amazon, or web.com to the particular IP address in order for the browser to load the internet resources. And uh, for each machine connected to the internet has a unique IP through which it is found over the internet. For example, I want to reach to your place. I want to meet you somewhere, wherever you're living. So what for me to get to your place, to meet you, I need a physical, you need to be physically present and someplace, right? So that is your home address. So unless and until I don't know your home address, I won't be able to catch up with you. Similar is the case for any website that you want to load. Unless and until you don't have the particular IP address of that website, you won't be able to find it. And domain name system removes the need for humans to memorize the IP address. That's quite evident. So talking about how the DNS works, uh, there are particular processes that DNS follows to in order for it to work. And the process for DNS resolution involves converting the host name into IP addresses. Like in this case, we have www.example.com. So it is converted through the help of DNS. It is converted to an IP address, for example, 192.168.1.1. And an IP address is given to each device on the internet, and that address is necessary to find the appropriate internet device, like a street address is used to find a particular home. Okay. To understand DNS resolution, we must know the stages a DNS query passes. So for example, I want the IP address of facebook.com, I don't have the particular IP. What I will do is, whatever my system does is it generates an DNS query. DNS query is nothing but a request that is basically generated to get the IP address for facebook.com. So the process or the stages that it passes through in order to get that IP address is what we are going to discuss. So there are four DNS servers. There are four DNS server involved in loading a web page. So these four servers, what are these four servers? These four servers are DNS recursor. Second is the root name server. Third is a TLD or top level domain name server. And the fourth and the last one is the authoritative name server. What are these? What are the functions of these? We will just have a brief about it one by one, starting with the DNS recursor. So the DNS recursor can be thought as a librarian who is asked to find a particular book somewhere in the library. For example, uh, you want a particular book. You go to a library, you want a particular book, and there's a bunch of books in the library. Someone who has been to the library, I believe everyone has. When you go to the library, you look for a particular book. There are various sections through which is divided, like mathematics section, science section, philosophy, and everything. So what you do is basically you go to a librarian who's sitting there, and you ask him or her in regards to a particular book. I want this book. Where can I find it? So the librarian, obviously knowing about the books, has known the placement, has a particular index in front of him, so he would be able to receive your query and then particularly help you or guide you as to where to go. Similar is the case here. The DNS recursor is a server designed to receive the queries from the client machine through the application such as web browser. So what you do is you go to the web browser, you type www.amazon.com. So what that does is it generates a query, a DNS query for the DNS recursor server, who is designated to receive the queries from the client machine. From your laptop, you open the web browser, you type in any domain name, a fully qualified domain name. It generates a DNS query. The DNS query is what it does. Where does the DNS query go? It goes directly to the DNS recursor server. DNS recursor server is nothing but just like a librarian who will receive your query. Moving to the next one is the root name server. What this does is root name server is a first step in translating, resolving human readable host names into the IP addresses. Root name server can be thought of an index of a library that points to a different racks of books. So this is the analogy that is given. Like for example, you went to the librarian to asking for a particular book. What he does is he opens the index. He sees where the particular books are, how the particular books are arranged. And for example, you're looking uh, for a philosophical type of book, some book you have just mentioned to him, and he will look through the index, find where the rack of the books are, where the rack of the book is, and he will guide you accordingly. Similar is the case with the root name server. It acts as an index of a library where basically it points out to a particular rack of books. In this case, it points out to a domain name which you are looking for. So this is the first server that helps in translating or resolving the host name into the IP address. Second is the top level domain name server. So the top level domain name server can be thought as a specific rack of books in the library. So you went to the librarian, he showed you index, and with that index, you basically knew where the books are. So what the top level domain does is it's basically specifying a specific rack of books in which your book is present somewhere there, but you have identified the rack in which the books are present. Similar is the case with the top level domain name server. What it does is basically it points out, it narrows down the possibility of finding the host name that you have entered and mapping it to a particular IP address. It serves as a next step in locating the IP address after the root server. It's if it hosts the last portion of the host name, example www.google.com. Here the TLD server is com. So what it is saying is that you have a fully qualified domain name like www.google.com here. So What the top level domain does is the last the bit, the .com bit. This is what the TLD servers points out to. This is where like you have various top level domain servers like organization org, like .com, like .in, .net, various top level domain servers. So how the address is broken down, how the host name is broken down, how these servers locate them, they move from right to left, from .com to Google and to www. So first .com is resolved, then Google is resolved, then www is resolved. Similarly, TLD name servers basically uh, helps you resolve the .com bit. And next comes the authoritative server. This is the final name server that can be thought of a dictionary of a rack books in which a specific name can be translated into a definition. It is considered as the last step of the name server query. If the server has a record for the DNS for the query, it will return the IP back and to the DNS recursor that made the initial request. So authoritative servers are the last step that we go to that basically point out to a particular host name that we are requesting for. These are the server that have the authoritative, there are the authoritative servers that basically point out to a particular host name that we are looking for after mapping it through the root server to TLD server and lastly to the authoritative server. It is considered as the last stop for the name server query as well. So this is the server which, if it has the record or the DNS record for the query that you are looking for, it will help you with the particular IP address which will be sent back to the DNS recursor. And if not, it will point out to an error message that this record is not found or 404 error would be shown up. So the difference between a recursive DNS resolver and an authoritative DNS server. What is the difference between them? Let's just find out about them. Talking about these, both servers are integrated into DNS infrastructure. Both of these servers are present in the DNS infrastructure. Both help in resolving the DNS query. Both the DNS recursive resolver and authoritative DNS server both help in resolving the DNS query. One prominent point is that the recursive resolver is the beginning and the authoritative server is the end. So when the query is generated from a system, from an end host, it firstly goes to the recursive DNS resolver, where which is basically responsible for resolving the query. And the last point where the query is basically resolved, finally resolved, is the authoritative DNS server, which is basically has the record to map the host DNS name, host name to the particular IP address. Recursive, talking about the recursive DNS resolver, it helps in responding to DNS requests from a client. What it does is it helps for responding the DNS request from a client and tracks the DNS record for that request. So resolver, as I already stated, that it takes the requests from the client that is basically trying to resolve an IP address, and it checks its DNS record or basically just forwards this query to the other servers in order to find out the IP address for that particular host name. It does this by making a series of requests until it reaches the authoritative name server, or times out or returns an error if the record is not found. So as the picture is stating down below, so from the client, the request is made, it goes to the recursive resolver. If the recursive resolver does not have the record for the host name that it is trying to identify or trying to break down to the IP address, map it to the IP address, it will go to the DNS roots name server. If the root name server also does not have the record, it's not present in its cache memory, it will go to the top level domain name server, and similarly the authoritative server, and which in turn would be having the final resolution for our request and would be sent back to the recursive resolver, which in turn would help us load the web page through the web browser. If the record is already present in the cache of the recursive resolver, that is the DNS recursive resolver, which is highlighted here. If the record is already present in its cache, it does not have to take multiple requests to fetch the data from the authoritative server. So if the record is already present there, so it does not have to go ahead with the request to root or TLD or the authoritative name server, it just forwards the same IP which the mapping has already been done in the DNS recursive resolver. It just forwards it to the client. That is what the DNS recursive resolver does. So the authoritative name server, as you might have already known by now, that it is the final resolution uh, that is the final server that is in this DNS pattern that we have, which finally resolves the IP to a particular host name. It actually holds a DNS resource record. All the records, final records, are basically held by these authoritative servers. This is a server at the bottom of the DNS lookup chain. So this is the chain of finding the IP. This is called DNS lookup chain, which helps to respond the DNS query made by the DNS resolver. So the authoritative server, if no server is having it in the cache memory, the authoritative server would be able to generate a valid IP mapping for the host name if the record is not present in any of the DNS resolver caches, DNS server caches. An authoritative name server can satisfy queries from its own data without needing to query another source, as it is a final source of truth for certain DNS records. So if the host name is valid, so it will be able to generate the final IP for the client to access the internet. So this was about the recursive DNS resolver as well as the authoritative DNS server. A basic idea you might have gotten as to what they are and how they are used. Moving ahead, there's also one more server that can be used, that is CNAME record. Uh, so what it is worth mentioning that in instances where the query is for a subdomain, it's not for the particular domain, it's for a subdomain. Like it is the same domain, but it's a part of this domain. It's not that domain exactly, such as blog.cloudflare. Like you use www.youtube.com. I would also like music.youtube.com. That's the same domain, but it's a part of that domain. It's a subdomain of that. Studio.youtube.com. That's also a subdomain of the same domain. An additional name server will be added to the sequence after the authoritative name server, which is responsible for storing this subdomain CNAME. So this, in short, what you need to know is that the authoritative server can have a subdomain, which, if required, can be contacted and which be able to fetch the IP for the particular host name. So again, what are the steps in a DNS lookup that we are going to understand next? Often DNS lookup information will be cached either locally inside the querying computer or remotely on a DNS infrastructure. So when you're trying to look up to or resolve a particular host name to the IP address, either it's present inside the host files of a particular system, or it's present in the cache memory of the DNS resolver that you're trying to contact via the DNS query. It may be present inside locally within your system in the host file of your system, or it may be present inside in the DNS resolver itself, uh, in the DNS architecture. So this is how it is done. Uh, there are typically 8 steps in DNS lookup. We are going to look for them. When DNS information is cached, steps are skipped from the DNS lookup process, which makes it quicker. So you might have seen various instances where you try to load a familiar website that you have visited before. The site loads pretty quickly. Then, for example, you're loading a site that you haven't visited for any time. It's a fresh site that you haven't visited before. You're trying to visit it. It takes some time. Why? Because it is going through a lookup process, and multiple DNS servers are queried just to get the IP address for that particular domain, fully qualified domain name that you have entered on your web browser. So this is something that the DNS lookup is. And if the information is already present inside the local machine, if the website has already been visited before, so it would be present, the information or the mapping of the host name would be present with the particular IP address would be present in the cache machine within the local machine in the cache data. So these DNS lookup processes are skipped for that. So there are 8 steps that are mentioned in the next slide. that we are going to state. And now stating about the 8 steps in the DNS lookup, what are these 8 steps? Let's talk about them. So the first one would be when a user types example.com, this time is trying to load in a site, namely example.com, into the web browser. And what happens is it's as soon as it is entered and enter is hit on the keyboard, it generates a DNS query that travels over the internet and is received by the DNS recursive resolver or the DNS resolver server. As soon as it is received by the DNS resolver, if the DNS resolver uh, has the particular IP address for that particular query, it will send it out if it's present in its cache. But if it's not, then the DNS resolver then queries the DNS root name server. You can see this the example.com. Just a second, let me just have this pointer. You can see this example.com. It's like, for example, it's www.example.com. There's another dot after the com that we generally do not use, but this represents dot after this, which represents a root server, a root name server, DNS root name server. So the DNS recursive resolver, if it does not have the IP address, what it does, it queries or it requests the IP from the DNS root name server. That's why this dot is present here. So after the query is received by the root name server, what it does, it responds to the resolver. It responds to the resolver back again that with the address of the top level domain name server, such as .com or .net. So when searching for example.com, our requested is pointed towards the .com TLD. So when the request from the resolver is sent to the DNS root server says, man, I don't have this IP address. So what I can do is let me just point you out to a server that might contain this information. As I can see, it contains top level domains basically contain all the addresses for .com, .net, .org, .mil stands for military. All these IP addresses are resolved from the TLD server, top level domain server. So what the root server does is it points out the DNS resolver to the TLD servers and checks whichever is present there. So in our case, which is example.com, so it points us out towards the .com TLD .com top level domain server. So once that is done, the resolver then makes a request to the .com TLD. Once it receives the address of the TLD server, it makes a request to the TLD. Hey man, for the TLD server, hey man, I'm just looking for the IP address for this host name. Do you have it? The TLD server responds with the IP address of the domain name server. If it does not have it, so it will just respond back to the resolver with the address of a domain name server, authoritative server of example.com. So lastly, the recursive resolver sends a query to the domain name server. Recursive resolver, after getting the address of the domain name server, what it does, the recursive server basically sends a query to the domain name server this time, asking for the IP address resolution. So the 7th step states that the IP address for example.com is then returned to the resolver from the name server. So once it is resolved, from the domain name server, it is returned back to the resolver that, hey, this is the IP that you're looking for. You can just share it with the client itself. The DNS resolver then responds to the web browser with the IP address of the domain requested initially. So once the host name is resolved to the IP address, the DNS resolver, what it does, it was the first step. The DNS resolver is the first one to send these iterative queries to all these domain servers just in order to resolve the IP address. So once that is resolved, the DNS resolver further sends the response to the web browser with the IP address of the domain requested initially. So let's have a little understanding through a diagrammatic representation, which makes it easy for us to understand it in a better way. So let's go through it. So this is the complete DNS lookup and a web page query. So what it does, for example, this is our laptop. This is our host, which we are trying to basically uh, get access to example.com in our case. So what we do is we send a recursive query. recursive query to the DNS resolver. Don't worry about it. We'll just know about these iterative queries and recursive queries later on in the video. For now, just understand that what our system will do, what our client will do, it will send a recursive query to the DNS resolver that helps us resolve the DNS query that we have. For in this case, we want to just know the IP address of example.com. So once the DNS receives this query from our client, if it's present in its cache, it will just forward the same the mapped IP address to the client. Then we don't have to follow this entire step. This will be bytecoded if basically if the cache of the DNS resolver contains the IP address for example.com. If not, then these steps follow. So DNS resolver will shoot as stated earlier in the for these 8 steps that we have already stated earlier. It will just communicate with the root server that give me the IP address. Root server will redirect it to the TLD server, top level domain server .com, .net, .org or .mil, whatever it is. In our case .com, so it will be the .com TLD, which will be basically redirected to. So DNS resolver receives the request, goes to TLD. Hey man, can I have the IP address mapped for example.com? TLD server shoots back an email, redirects it basically to the domain name server. So DNS server, once it receives the request from TLD server, it goes to the example.com or the domain name server, requesting for the IP address mapping of example.com. Once example.com is present there in the domain name server, it shoots back an iterative query that here is the IP address that is mapped to this example.com. Once the DNS resolver has the IP address, it gives the IP address to the client, through which it is able to basically communicate with the server of example.com over the internet. So these are the steps. Once the 8 steps of the DNS lookup have returned, the IP address of, for example.com, in our case, the example.com, the IP address has already been returned. The browser would be able to request for the web page from the server. The browser makes HTTPS request to the IP address. It has the IP address. Now it will be able to communicate with the server, and the server at the IP returns the web page to be rendered on the browser. So once we have the IP address, we will be able to load the page, for example.com, and the communication can be established with the server. So this was a complete DNS lookup, how it works, how the communication happens, how the IP address is basically resolved uh, by the DNS servers. So lastly, there are three DNS queries, types of DNS queries that we are going to look up for. There are 3 types of DNS queries. Those queries are recursive query that we have already seen, like in this case, from the client to the DNS resolver, we have having the recursive query, and from the DNS resolver to the other to the other DNS servers, we are having the iterative query. What these are, what are the functionalities of it? These are basically the types of DNS queries. So we're going to know about them one by one, what they are and what are the functionalities of them. Starting with the recursive query. In a recursive query, a DNS client requires that a DNS server, typically a DNS recursive resolver, will respond to the clients with either the request resources record or an error message if the resolver cannot find the record. So in a recursive query, what happens is that DNS client, that is laptop in this case, when it requires when it requires that a DNS server, typically what it does, it requires basically a DNS server. In our case, it firstly contacts with the DNS resolver itself, typically a DNS resolver. So it wants it to respond with either the IP address, or will respond with the client with either the requested resources, that is the IP address. It just wants it to map the host name to the particular IP address, or if it's not able to map it, just return back an error message if the resolver cannot find the record. So this is a recursive query that we can say. Talking about the iterative query, what it stands for, what it is. So an iterative DNS query is a request where the DNS server has no relevant DNS record in its cache. So when the DNS resolver, as in this case, as we have stated, this DNS resolver does not have the IP address of example.com present in its cache, the built-in memory for that is present, it's not basically having the IP address for example.com. So what it does, it generates an iterative query. What is an iterative query? A DNS resolve iterative query is a request where if the DNS server has no relevant DNS record in its cache, it refers the DNS client to another DNS server. In our case, the DNS resolver basically contacts with the DNS root server, then the TLD server, then the top level admin, authoritative server, and through which it is able to basically get the IP address. The process repeats, that is iterates. So the repetitive process is called the iterative process. So iterative query is based on this. The process repeats itself until one of the queried DNS server returns the correct IP addresses for the domain. So in such situation, the DNS client will allow a DNS server to return the best answer it can. Either if it has the record, if the host name, fully qualified domain name is relevant, it will have a record somewhere over the internet, somewhere over the DNS authoritative server. Once it is contacted by the DNS resolver, it will just basically give the IP address for the same. So non-recursive query is just basically the opposite of what the recursive query does. Non-recursive query is a type of DNS query where the DNS resolver already knows uh, the the answer and can immediately return the DNS record and query the DNS name server. Okay, so for example, in this case, what is a non-recursive query? For example, I'm looking for the example.com. I'll just send a query, a DNS query to the DNS resolver, stating that I want this address to be resolved. So if the DNS resolver already has it in its record, whether how it can basically communicate with the authoritative server or the domain name server, it will just shoot a query to that root domain server and request for the IP. So boycotting these root server and TLD server, it will just shoot a query to this and get the IP resolved and then share it to the client, which will be able to communicate with the browser itself. Okay, so this is what it is stated. Our non-recursive query is a type of DNS query where the DNS resolver already knows the answers and can immediately return the DNS record or query a DNS name server. If it's present in the cache, it will just shoot out the IP address to the client, or it will just contact the DNS domain name server. The DNS resolver may already have the record stored in the local cache, or it may query the DNS name server that is authoritative for the record. And authoritative DNS server is guaranteed to have the correct IP address for the hostname. So this was all about and the non-recursive query. So the lastly, we have the DNS caching. What this caching means, this is very simple, as I have already stated over the video. The purpose of caching is to temporarily store the data in the location to improve the overall performance. So once, if the data is already present in the DNS resolver, for example, if the IP is already resolved there, then the resolver does not have to shoot the iterative queries just to get the IP resolved. If it's present there, the CPU utilization, the memory utilization will be far less, and the query will be resolved immediately. The DNS caching involves storing data close to the requesting client so that the DNS query can be resolved quickly and to minimize additional queries down DNS lookup chain. As already stated, it basically helps in quickly resolving the query and does not have to go through the DNS lookup chain. There are particularly, obviously, there is a time for this cache of DNS cache. Uh, the mapping of the host name to the IPs is for a particular limited time. This is known as time to live. And thanks for watching. This was all about the DNS. I hope you liked this session. If you liked, please do like, comment, and subscribe to our channel. Obviously, have a wonderful day and keep watching, keep learning.